Hey guys, it's Chris at Highline Guitars. You're watching another one of my YouTube guitar building videos. If you're new to my channel, welcome. I hope that by the end of this video, I'll have earned the honor and privilege of your subscription. And of course, to everybody who's watching, if you enjoy this video or get anything out of it, or just want to show me some support, be sure to click that thumbs up button. It helps me and it will help you. Okay, so what I'm going to be talking about in today's video is the CNC strategy that I plan to employ as I build this 6-string multi-scale guitar. I have always built one-off, unique custom guitars. I don't build small batch production runs, and I certainly don't want to become a big production company like, you know, Fender, Gibson, Ibanez, PRS, or anything like that. That's not where my interest or my heart lays. I like to build unique, one-of-a-kind instruments. As a result, every guitar that I build requires a slightly different approach to the strategy that I will use to cut and carve those parts. And you know, in the past, CNC was always thought of as a way to mass produce the same parts over and over and over with a high degree of reliable consistency, repeatable consistency. And while that was true, the main reason it was true was because the front end, where the software that you use to design the parts, to assign the tool paths and write the G code, was so complicated that the idea was once you created your files, you could just use those same files over and over and over. So you put in a lot of effort to create those designs and to write the G code, but then once it was done, you could step back and just focus on making those same parts over and over and over. Well, in recent years, the software has become increasingly easy to use, and in the future, it's going to get even easier to use. As a result, it becomes attractive to guys like me who just want to build one unique guitar at a time. And we want our guitars to be like our fingerprints. No two are ever going to be the same. Well, with the way things stand right now with software, that is certainly possible. I can design a guitar neck or a guitar body in 3D in about 30 minutes. And then 15 minutes later, I've got a G code file that's ready to cut. So it's pretty quick. And when you compare that to the length of time it takes to make a wood or plastic template for routing out your guitar parts, the software is getting to the point where it's much faster and much easier than the old traditional methods. So, and the other benefit is when you're setting up your shop and purchasing the equipment that you're going to need, if you're doing it the sort of the old school way, you're probably going to have to get a table saw, a bandsaw, a drill press, a joiner, a planer, all those big heavy duty tools. Oh, and a router. But with CNC, you can pretty much replace all those parts with just a CNC machine. So the money that you would spend on all that big expensive equipment, you can spend on a pretty decent quality CNC machine. So back to the whole issue of CNC strategy. For this guitar, my strategy will be a little bit different than what I did on the last guitar that I built. And I use the same software programs always. I'm using Adobe Illustrator, Rhinoceros 3D for the Macintosh, Meshcam, and Easel Pro. So, but it's how I use those programs and what operations are done with what program that is really the strategy that I'm talking about. Now, what drives my strategy, and this is probably the most important part of this whole video, I have a simple rule of thumb that I follow. If the carving operation is going to involve carving a 3D shape, like a curve or a contour or angle or bevel, then I'm going to use CAD software to create a 3D model, and then I'm going to export that model and import it into my CAM software, MeshCam, and I'm going to assign the tool paths and write the G-code. If, on the other hand, the carving operation is going to be two-dimensional, such as a pocket or drilling a hole straight through the wood or cutting a slot, then I'm going to use the elements that I created in Adobe Illustrator, and I'm going to import those into Easel Pro, and I'm going to assign the tool paths at that stage because it's a 2D carving operation. But it depends on the design of the guitar as to what operations are going to be 3D and what operations are going to be 2D. And sometimes along the way, I'll make a decision that instead of drilling a hole with my CNC machine, it would make more sense just to walk the part over to my drill press and drill a hole there. Now you're probably wondering, if I have a CNC machine, why do I have a drill press? Well, it's because I started out building guitars the old school way, using a lot of hand tools and powered hand tools to build my guitars, but then I progressed into CNC. So I still have a lot of those old tools. They just don't get as much use as they used to. So what I'm going to do now is we're going to jump on the computer, and I'm just going to kind of give a brief overview of my CNC strategy, just so you can kind of get an idea of the decisions that I make to arrive at the point where I'm ready to start carving the wood on my CNC machine. So let's jump in and get started. Okay, so here we are on the computer, and what you see on the screen is the two-dimensional design that I created in Adobe Illustrator. And I've talked about this process before in previous videos as I have walked you through how I create all the different files. And what I'll do is I'll put a link up above to the playlist for this particular guitar build, and you can go back and watch those videos if you want to see how I create these 2D drawings as well as the 3D drawings that or 3D models that I create. So, but this is the Adobe Illustrator file, and I use that to create this is the 3D model that I created in Rhinoceros. And this is just obviously the body with all the pockets, and it's both front and back, so you see the whole thing here. But what I'll do then is I will export this as an STL file, which I will then import into my CAM software, which is MeshCam. And this is what it looks like when it imports into MeshCam. The green that you see are the tool paths, and there's 3 tool paths here. There's a roughing operation, which hogs out most of the wood, but it leaves a stair-stepped surface, which obviously would require an extensive amount of sanding to smooth it out. So I will then follow that roughing operation with first a finishing pass that follows along the x-axis, which is back and forth, side to side, all the way across the length of the body. Then I'll do another finishing pass, which goes back and forth from front to the back of the guitar body. So 90 degrees opposed to the first finishing pass. And that results in a very smooth surface, one that I can usually get away with sanding most often with 220 grit sandpaper, although sometimes if I'm in a real hurry, I'll do a finishing pass that's not quite as refined, so then I have to back down to like a 150 grit. But I try to keep it to the 220. It just makes it a lot easier. But then what I'll do is I will save this, and when I save it, I have all these options, all these different types of CNC machines. And this is one of the reasons why I don't offer G-code with my plans, because you may be using a different CNC machine that I'm using. And the G-code that I'm writing for my situation, it's with an X-Carve Pro, but I'm also using what would probably be different bits than what you would be using. I'm also maybe carving out of different material than what you're using. And that's what people have to understand. G-code is written specific to the machine that you're using, the bits that you're using, and the material that you're cutting out of. So that's why I don't offer G-code, because I don't know what you're going to be, how you're going to be doing this. So I just use a basic G-code inch, and I'll save it to my computer, which I've already done. And at that stage, I'm ready to start organizing my files into Easel Pro, which is not only a program that I can use to author some of my G-code files, primarily my two-dimensional G-code files, but it's also the program that I will use as my G-code sender. It'll send all my files to my CNC machine so that I can cut them out. And what's nice about this is it keeps the project organized in one location. I have my 3D files, my 2D files, all organized in one place. So I can set that up as an order of process, an order of cutting operations, and keep things much more efficient, which in the end can help make the process more efficient. When you have efficiency, you typically have better craftsmanship. Okay, so what I have on the screen here is my Easel Pro project file for the 6-string multi-scale guitar. And you know that's what it is, because if you look at the upper left corner of the screen, it says 6-string multi-scale guitar. Every time I start one of these projects, I create a new project, and it allows me to organize all the different carving operations into one place. And that's really handy, because I have found that when you're doing CNC work, you want to follow a certain order of operations, and that keeps everything as efficient as possible. And like I just said, efficiency translates to craftsmanship. So what I typically do when I build a guitar, I like to make the fretboard first, all the way to completion. And that means cutting the slots, drilling the marker dots, carving the radius, and then cutting out the perimeter shape. So it's made all the way to completion. And if you look here on the left side of the screen, you'll see this is the actual layout of the fret slots. And they're just, the lines that represent each slot. And that's what's going to determine the cutting path for the bit. So if you look at the upper left or the upper right corner, I have my material selected as rosewood, and it may be rosewood or it could be maple. I haven't decided yet. Probably going to be rosewood though. The bit I've selected is my 0.024 inch diameter 2-flute spiral upcut bit, and I have that actually added as a bit into Easel Pro, so I can always select that when I'm going to be cutting my fret slots. And the 0.024 inch bit is perhaps slightly larger than the normal curve of a fretting saw, which is like 0.023 inches, but that difference is so fantastically small it doesn't really matter. Besides, I glue all my frets in with CA glue. And then I can set the cut settings, the feed rate, the plunge rate, depth of pass, all that good stuff. And I like to use a vertical ramp that you see here at the bottom of this dialog. That introduces the bit gradually at a 20-degree angle down into the cut. That way you're not plunging the bit and driving it forward through the full thickness of the wood, which could damage the bit. And that's especially important with these really tiny fret slotting bits. So that's how I do this. And this is a 2D cut. This was this was imported from my Illustrator file, and it dropped right in. And when I laid out the rosewood dimensions, I made the dimensions exactly the same as the dimensions of the document in Adobe Illustrator, so that each of the successive carving operations will be precisely registered, and it's based on the 0, home position in the lower left corner of the blank. And you can see that on the right side of the screen, where the bit actually starts in this 0 corner and then moves out. So then the next carving operation is to do the holes for the marker dots. Now for this particular guitar, I'm using 1/4 inch diameter marker dots. So I'm just going to be drilling 1/4 inch diameter holes. And I'm just going to use the regular 1/4 inch 2-flute spiral downcut end mill instead of an actual drill bit. Because the problem with a drill bit is the tips usually come to a point, or they're a brad point bit. And when you probe it to determine the Z-axis height position, if it's got that point on it, you're not going to be drilling the hole deep enough into the wood. So I like to use an end mill because the bottom of the end mill is flat, assuming that I'm using a flat end mill and not a ball nose end mill. But for this, I'll be using a flat end mill. And then once I've drilled these holes, the next thing I'll do is I'll fill them with the material that I'm going to use for the marker dots. And that could be anything from mother of pearl to glow-in-the-dark powders to other pieces of wood. A lot of times I'll use a plug cutter and I'll cut 1/4-inch diameter plugs from a contrasting piece of wood, and then I'll glue them in to those holes. And I could do that for this. I haven't fully decided that yet. But then once that's done and whatever material I've installed has thoroughly dried and is ready for the next step, I'm doing all of this on the CNC machine. I leave the blank clamped down to the CNC machine and I won't move it. The next carving operation, this is my first 3D carving operation, and this was generated from the 3D file that I saved out of Meshcam from the 3D STL file that I imported. And this is just the radius. And I'll cut this. There's 2 passes here. There is a roughing pass, and you see that right here, followed by a finishing pass, which goes all the way to the end in one direction and then all the way back and forth across the width in the other direction. And you can also see down here in the below the file here in the screen, you can see an estimate of the time it's going to take to do this. So to fully radius this will take about 42 minutes. And the end result is going to be a perfectly formed conical radius, 16 inches at the heel, 10 inches at the nut, and so smooth I could go with 220 to 400 grit to finish the surface in preparation for installing frets and then applying finish later on. But then once that's done, the next thing I have to do is cut out the perimeter shape. So I have a 2D carve here set up, and this is with an 1/8 inch 2-flute spiral upcut bit, and that will cut all the way through the board, thus liberating, well, it is in preparation for liberating the fretboard. There are tabs which will connect the fretboard to the blank, because the blank will be clamped down, but not the actual fretboard itself once the bit has cut all the way through. If I didn't have tabs linking the two, the fretboard could fly around the machine once the bit has cut all the way through. And that could damage the fretboard, it could cause injury, it could damage your CNC machine. So you have to have those tabs to keep everything in place. And then once it's done, you can unclamp the blank and then take a small saw and clip those little tabs to liberate the fretboard from the blank. Before I continue with this video, I wanted to explain that the plans that I'm creating for this specific guitar are also going to be available on my eGuitar Plans website, as well as my Highline Guitars YouTube merch store, which is displayed below the description for this video. At any rate, links for both of those sites are in the description. But what I plan to do with this particular guitar plan is I'm going to include both the STL files as well as the SVG files. That way, really, no matter what your CNC strategy is, you'll have the files necessary to set up your cutting operations. And even if you don't have a CNC machine but would still like to build this guitar, you can purchase the plans and use the plans to create templates to build the guitar using more traditional methods. So I just wanted to make that clear. Then it's time to move on to the neck, and I'm going to start out by cutting the slot for the truss rod, which you see here. This is another 2-dimensional cut, and I'm using a 1/4 inch bit to do that. And you can see on the left side of the screen the actual file for that. And then up here I have set up the material 5 inches wide, 30 inches long, and a little over 1.5 inches thick. And then I've got my 1/4 inch 2-flute spiral downcut bit. And I like to use downcut bits for shallower cuts on the surface because it leaves a cleaner surface. If I'm using an upcut bit, it's going to leave a fuzzy edge, which has to be cleaned up. So using the downcut bit just makes that a little easier to do and requires less post-processing. And then I have my cut settings here, 160 inches per minute feed rate, my 48 inches per minute plunge rate. Depth of pass is always equal to the diameter of the bit, and then the speed of the spindle is 16,000 RPM. And again, I'm doing that 20-degree ramp. So that's the first cutting operation for the neck. And then while the blank is still clamped down on this side, I'll do the headstock. And the headstock is just going to be cutting the surface shape of the headstock. And again, it's a 2-pass cutting operation with a rough pass to begin with. And then that's followed up by a finishing pass. And the finishing pass will smooth out the surface to where I can just sand it with 220 grit and it's good. Now, once I've done this, I then have to flip the blank over, flip it upside down and clamp it back down, and then I'll cut the other side. And this is that file. And it looks just like a big blue blob, but what it is it starts out as a rough cut, and it's going to cut out the back shape, the heel, the contour of the shaft itself, and then the headstock. Then I follow up with a finishing pass to clean up and smooth out the surface. Once that's done, what I'll do is I'll remove the blank, I'll cut the tabs to liberate the neck from the blank, and then I'll walk it over to my drill press and I'll drill the tuner holes. Now you're maybe wondering, why don't I drill the tuner holes on the CNC machine? Well, the problem is because this is an angled headstock, I would have to remove the neck from the blank, and then I'd have to have a fixture that I could clamp down the neck so that the headstock would be flat on the surface of the wasteboard in order to drill those holes straight through the headstock. Well, that's an awful lot of work when I can simply walk over to my drill press and in just a minute or two drill all 6 holes for the tuners. So I opt to do it that way. It's much faster. But then once that's done, I can glue the fretboard to the neck. I can finish sanding the neck all the way to, say, 220, 320, 400 grit, whatever I want to finish at. I could even go as far as to install the frets and do all that work and then set the neck aside. Now, I've stressed this before. I like to make each part, the fretboard, the neck, and the body, all the way to completion before I bring them together. I know a lot of guys will take a big neck blank and they'll glue a fretboard blank to it, and then they'll start carving the neck, and then they'll start carving the fretboard. The problem is, if you make a mistake, you've ruined both pieces of wood. Whereas in this situation, if I have a problem with one, I've only lost that one piece. I haven't lost both of them. So I like to make each piece separately all the way to completion, then bring everything together. I rarely lose any parts. Occasionally I may, in the process of carving a neck, I may discover a knot or a wormhole or something that I couldn't see on the surface when I selected the blank. But once I carve the neck and form that shape, I might reveal something that's going to be a problem. If that's the case, I've lost just the neck. I haven't lost the fretboard as well. So that's kind of my philosophy about cutting these parts on my CNC machine. But once the neck is done, and I can set it aside, and I like to do that to let it sort of rest after all the carving, the gluing, and all that stuff, all the sanding and everything. I'll set it aside, and then I'll focus on making the body. And the first step in making the body is I'll start out on the front side, and I will drill all the pilot holes for mounting the bridge as well as installing the pickups. And this is done with a 16th inch bit, which isn't always the ideal size for a pilot hole for every screw. But the problem with CNC is, unless you have a large collection of collets, you're kind of limited in the drill bit size that you can use. And in my case, I've got an 1/8 inch collet and then a 16th inch collet. So I can use either an 1/8 inch bit or a 16th inch bit. If I really feel the need to enlarge from a 16th inch to slightly larger, I can always, once the pilot hole has been drilled with the 16th inch bit, I can enlarge it with my drill press if I feel that's necessary. It rarely seems like it's necessary to do that, so I don't really bother with it. But then after I drill these holes, the next step is to begin the process of cutting the pockets. This operation starts out by making a shallow pass with a 1/4 inch diameter 2-flute spiral downcut bit. And as I said before, the downcut bit is used at this stage because the surface it leaves is much smoother and cleaner. If I were to use an upcut bit here, the edges of the pockets would be really fuzzy. And there's also the possibility of some tear out depending on the species of wood. Some species of wood are more prone to tear out, such as poplar and alder. But any species can suffer that issue. So I'll start with this downcut bit, and I'm only going to make a pass that's about 1/4 inch deep. Once that's done, I will switch bits to a 1/4 inch upcut bit, and I will finish cutting the full size and depth of those pockets. Now, the reason I don't leave a downcut bit in the spindle to do these sort of cutting operations is when you start drilling or cutting to this depth, you fill the pocket with chips with a downcut bit, and it could get so packed full of chips that you could actually impede the movement of the bit. The bit can heat up and then it can break. So you want a bit that's going to evacuate the chips quickly. So I use an upcut bit since it pulls the chips up out of the wood and reduces the potential for a broken bit. And then once that's done, I will proceed with my 3D carving operation for the front of the body. And that is essentially the entire bevel all the way around the perimeter of the guitar. And I have my 2 carving operations. The first is the rough cut, and then the next one is a parallel finishing pass, followed by another parallel finishing pass in the opposite direction. And that results in a really super clean surface. And this will take about 2 hours to cut this. It's not super fast, but it's certainly faster than doing it by hand. So then once that's done, I can then flip the body over, the blank over, clamp it back down, get everything repositioned as far as the spindle home position is concerned. And then I can start with the operations on the back of the body. And the first one is going to be the pilot holes for the neck mounting bolts. And those are drilled in. And then after that, I will switch to my downcut bit again, my 1/4 inch downcut bit, and I will cut the holes for the recesses for the ferrules, the neck bolt ferrules. And then for the recessed shelf that will support the control cavity cover. Once that's done, I'll switch to an upcut bit, and I will finish cutting the full depth of the control cavity pocket. And then the next operation is to drill, and you probably can't see these on the screen, but there are 4 tiny holes. These are pilot holes for mounting the control cavity cover to the body of the back of the body of the guitar. And then the last carving operation is going to be to cut the back bevel onto the guitar. And this will also include the side. And where you see these curved arches here in that path, that's where the tabs are all the way around. And the tabs, this allows me to cut the full perimeter shape and to leave the tabs so that the body remains attached to the blank and won't go flying around once the bit is cut through. So once this is done, I can then move the spindle out of the way, remove the clamps, and then liberate the body from the blank. And then the very last part that I have to cut is the control cavity cover itself. And this is done with a 1/16 inch 2-flute spiral upcut bit. Now when I do this, I'm importing an SVG file from Adobe Illustrator, same as I do the other 2D cutting operations. But what I can do in this situation is I can determine the cut path, and the bit can either be right on the cut path, on the inside of the cut path, or on the outside of the cut path. In this case, I'm doing it on the cut path because the bit is a 1/16 of an inch in diameter. that means the actual control cavity cover is going to be a 32nd of an inch smaller all the way around than it would be if I were to cut on the outside. And it will be a 32nd of an inch smaller than the actual cavity, the shelf that I made, this part here, where the cavity will sit. That way the cavity will fit nicely into that cover without being jammed too tightly against the edges of that recess. If that were to happen at some point, if the wood were to swell with a change in humidity, it could split that control cavity cover. So I want a tiny gap all the way around just to reduce that potential from happening. So I will cut with the bit on the path. With other cutting operations, like when I did the pickup pockets, I'm actually cutting on the inside of the path, because if I were to cut on the path, the pockets would be too large. And so I cut on the inside of the path so that the cavities are the actual size that they're supposed to be. Okay guys, well that pretty much covers the CNC strategy that I follow. There's probably a lot more to it than I'm filling you in on here, but I think that once you get kind of an idea of the software programs that I use and the decisions that I make regarding whether I'm going to use 3D carving or 2D carving, it all pretty much makes sense and it's not that complicated. So I hope you've enjoyed this video and found something useful. If so, be sure to give the video that thumbs up. Click that thumbs up button. It's so important. And if you're new to the channel, welcome. I hope that I have earned the honor and the privilege of your subscription. And again, to everybody out there, I hope that you'll be back for the next episode in this exciting guitar building project.